on to a more challenging problem. We have an 8 kilogram puck moving at 2 meters per second, striking a 2 kilogram puck at rest. After the collision, the pucks move as shown. So here's before, coming, hitting off center, and then they're going off in these directions. Find the values of the velocity in the x direction and the velocity in the y direction. Alright, so let's start with x, because you see that this is velocity at an angle, so we have to separate them into their components, and we have to keep x completely separate from y. So we're going to start with x, and we've got our conservation of momentum. The momentum before has to equal the momentum after. In this instance, we have two objects, so momentum 1 initially equals momentum, momentum 1 initially plus momentum 2 initially equals momentum 1 at the end plus momentum 2 at the end, because there's two objects after. So we can tell that this is object 1 and this is object 2. Object 2 has no momentum in the beginning, so that goes away. We're looking for the final velocity of the 8 kilogram puck. So we're looking for, this is 1 and this is 2. Don't let that diagram fool you. Notice the masses are labeled for you. So we're looking for the final velocity of 1. We're going to find that in this term right here. So before I start putting in my variables and all of those hundreds of subscripts, I'm going to move this guy over here. Subtract P2F from each side. So when I do that, I have P1 naught minus P2F. And that's going to save me just a little bit of headache. Next step. Now we're going to break it apart. M1 V1 naught minus M2 V2F equals M1 V1F. And remember, this is all in the x direction. I haven't written the x here because I mentioned that we're doing just the x direction first, just the horizontal first. So now I can divide M1 from each side, and I can plug in my numbers and solve for my final velocity for object 1 in the x direction. When I do that, it's 8 times 2 minus 2 times, we gotta resolve this vector into its components. Alright, so how do we do it? On the x, it's going to be magnitude, which is 10 cosine 53. 10 cosine 53. When I do that, I get 6 meters per second. So it's 2 times 6, which is 12 divided by 2. I'll write it. Okay. There it is in number form. All I did was just plug in all of that stuff. And when we do all of that, we get 0.5. So my velocity in the x is 0.5 meters per second. What about in the y direction? Well, the y direction, I'm going to have to erase all of this. So for the y direction, we are now going to do the same equation, right? Because our momentum has to be conserved in the x direction and in the y direction. So P1 naught plus P2 naught equals, and yeah, you can skip forward on this because it's the same exact thing that we just did. Just plug in your numbers and check yourselves. So when we do this, but if you're still unsure, I'm going to go through it again. That goes away because object 2 is at rest. We're looking for the final velocity in the y for object 1. We're going to find that in this term. So when we subtract P2F, we get P1 naught minus P2F equals P1F, which is the same thing as M1 V1 naught minus M2 V2F equals M1 V1F. dividing by m1 on each side will give us our final velocity, and now we can plug in our numbers. And when we do that, we have 8 times 2 minus, be careful when plugging all of this in your calculator in one step. Use parentheses like they are free. m2 is 2 times our final speed in the y direction. Oh, we got to do that too. 10 sine theta. And we get 8 meters per second. Divided by m1, which is 8. And when we put those together, we have 2 meters per second. Now, if we wanted to actually find out what is the final velocity, we would plug these two into Pythagorean theorem and find this hypotenuse, and that'll give us our final velocity. We can also figure out the exact direction. Remember, it's been a while. The direction, the angle, equals arctangent y over x. So it's arctan, or inverse tangent, 2 over 0.5. And that will give you your direction. Okay, so now let's figure out, is this collision inelastic, elastic, or an explosion? We can look and we see we have two objects and they crash and they go separate ways. So we would think it's going to be elastic, but let's just verify it. How are we going to verify it? If we go back a few videos, we've got this thing here. Relationship. So if final kinetic energy is greater than initial kinetic energy, we have an explosion. If the two are equal, then it is elastic. If the final kinetic energy is less than the initial kinetic energy, then it's inelastic. And if the final kinetic energy is much, much less than the initial kinetic energy, it's totally inelastic, sticky. So let's look at the kinetic energy before compared to the kinetic energy after of this system. So when we do that, what kind of kinetic energy do we have in the beginning? We've got only one of these things are moving for the left side of the equation, right? So then all we're dealing with is this velocity. So 1/2 m, which is 4, times v squared, which is 4. Kinetic energy before is 16 joules. After, what are we looking at as far as kinetic energy goes? Well, now we have two objects that are moving, right? So we have two different velocities. So let's go ahead and figure out what is this actual velocity here. I told you earlier it's going to be Pythagorean theorem, so it's 0.5 squared. So 0.25 plus 2 squared, 4. So I got 2.06, but I'm just going to call it a 2 meter per second. So the kinetic energy before, kinetic energy 1 plus kinetic energy 2 equals kinetic energy total. So we have 1/2 mv squared here. 1/2 of 8 is 4 times v squared is 4, so that's 16. Plus this one up here, half of 2 is 1 times 10 squared is 100. 116 joules of energy. Much, much greater. This is an explosion. Momentum is conserved.